quick. What's going on? Box running on, so yeah, we're going to need cups. Yeah, so let's divide first. What's 36 divided by 6? 6. Now times 4. 24. Yep, easier. You have options, right? Oh. Try to make the number smaller if you can. I like doing division first if it makes the number smaller. If it doesn't divide evenly, then I forget it. But if you can.
It exploded there.
Yeah, I know. That's the bad one here. Do you know where the other piece is?
Right there by your tape.
Okay. All right, so let's look at number 2 now. Are you okay?
I don't understand this one.
Number 1 or
number
different
2.
one? Number 2? I'm going to go do number 2 right now. Okay, so you can watch. And then if you have a question, ask. Okay, does that make sense? All right, so Xavier on number 2. Turn your page, please. Red.
Yeah, I already have this one down.
All right, great. You're going to watch, though.
Oh.
Because understanding is different than having it done. Okay, so this just says, given a triangle ABC. Great. Okay, it's a triangle. AD and BF are congruent. So that means these two are congruent. AD and BF. You with me? Okay. CD and CF are also congruent. Well, that tells us CD and CF are congruent. So those two go together. We also know that DE and AC, they hit each other at a 90 degree. That's what that means. It's perpendicular. So DE hits AC at 90. So those are 90 degree angles. Same thing here with EF and CD. So those are 90 degree angles. Okay? All right. So that takes care of all those. We're going to prove that E is the midpoint. So to be a midpoint, it means that this and this must be the same, right? It divides it into equal pieces. So if we can prove this and this is the same, then by definition, E is a midpoint, right? It fits the definition of midpoint. Does that make sense? Okay. So to prove these two segments congruent, I need to prove these two triangles congruent, right? Because if the triangles are the same, then their parts will be the same. Right now I only have a segment and a side, or I'm sorry, an angle, side and an angle, right? So I need more information. Notice that I do have 90 degree angles here, which means HL is on the table. So if I can get that leg in this side, right, I'll have hypotenuse leg. But the thing is, if I knew this side, right, then I'd be done. So spoilers, we're not going to end up using HL. Because if we were using that, then we should have ended the proof a while ago, because we would already have this. So we're going to need some other information. So what other information can I get? Well, if you look, this side is made up of the red and the blue, right? So red plus blue gets me CV, right? Well, if you look at AC, isn't AC also red plus blue? Well, if this is red plus blue, and that's red plus blue, it must be the same, right? So what that is we said the two small segments make up the big segment, right? That's segment addition postulate, where you're allowed to add up two segments to make a big one, right? That's it. So by segment addition postulate, I know that AC must be the same thing as BC. Right? Make sense? Okay. Now what does that get me? Well, if these two sides are the same, ABC's isosceles, isn't it? Right, we get two sides matching, right? So two of my sides are matching, so this triangle, this big triangle, is isosceles. Well, if it's isosceles, we can use isosceles triangle theorem, which says if two sides match, then their opposite angles match. Right? Okay, so by isosceles triangle, that's the symbol for it, theorem. And it's the theorem because I started with the sides and it got me the angles, right? I know that angle A is congruent to angle B. And I can call it angle A because there's only one angle A. Angle E, there's lots, right? So I've used three letters like D, E, F for the top angle or A, E, D for the side, right? Here, angle A is fine. So I've got that now. And if you look, now I've got angle, side, angle. So those triangles are congruent. So this triangle and this triangle are congruent. I put dots there just so you know what I'm talking about. It's not an official thing. So, by angle, side, angle. And it's angle, side, angle, not angle, angle, side, because if I did angle, angle, side, I'd be going way around, right? I'd be skipping a side, an angle, and a side to get there. Does that make sense? Angle, side, angle's right next to each other, so it's fine. At most, you can skip one thing. So for instance, if I had two angles here, right? I could do angle, angle. That's fine, because I only skipped the side, right? But skipping all that stuff is not okay. So angle, side, angle is what I got. So triangle ADE, that's this guy, right? Is going to be congruent to this triangle. Now I got to match them up. A is the red side and the unknown hypotenuse. So red side and hypotenuse is B. D is the next letter. D is made up of red and unknown side. Red and unknown side is E. Makes sense that the 90s go together, right? And then E is going to go with itself. Or not E. That was F. E is going to go with itself. My bad. D and F go together. A and B, E and E. Okay. And that's because E is made up of the hypotenuse and the unknown side. Hypotenuse, unknown side. Okay. So now we know those are congruent. Remember, our goal was to prove that E is the midpoint. So we need these two segments to be congruent. Well, if the triangles are the same, their parts should be the same. So let's check. A, E, and B, E. A, E, B. Are they corresponding? Yeah, they're in first and third position, right? So we can use CCP. By CCP, A, E. You okay with that? Right? Again, we can only use CCP if we know the triangles are congruent, which we do. And then we can say the corresponding parts will be congruent, right? Corresponding means same relative spot, first and third. Okay? So we can. If we wanted to, we can also say DE is congruent to FE, DE and FE, right? Because they're in the same spots, second and third, right? But we wanted these. So that's what I went after. Now, by definition, E is a midpoint, right? Cuts it two equal halves. So by definition, E is the midpoint of A, B, and we're done. Again, always end with what they want you to say, right? Right there. How do you feel?
How many information do we have to use the isosceles?
Say it again.
How many information do we have to use the isosceles?
So if you have this, then you can use this, right? That's the theorem. The converse is this. Okay? Sides get angles. So we had sides, so we get angles. Here, if we had angles, we could get the sides as well. That's the reverse. Does that answer your question?
Yeah, but like the first that we mark, we already have side before the SAP.
So red and blue makes this side, right? And red and blue makes this side. So these are the same. Right? And if those are the same, then we have this, right? And then we have that. Does that answer your question? I think I'm misunderstanding your question.
I think I got it.
For real?
So we have to so if it's we have to use the SAP.
Yeah. SAP is two little guys add up to the big guy, right? Does that make sense? Or big guy minus little guy gets other little guy. Does that make sense? Right? Black minus blue gets red. Black minus blue gets red, so they must be the same, right? Good question. How do you feel, Xavier? Feeling good about this? Okay. Let's look at 3. And how are you doing?
Oh.
All right. Okay. This is what we want. Let's set up with what we want, right? And then let's start with something that either has tablespoons in the top or pints in the bottom, right? You can flip them if you want, right?
Okay.
So start with that being equal this, right?
Okay.
And now you're going to pick something that either has tablespoons or pints in the start, right?
Okay.
And the bottom, right?
Mm-hmm.
And then try to cancel stuff from there.
Okay.
You know how to set this stuff.
Yeah.
You got it. All right. So given triangle ABC, AC congruent to BC. Xavier, as soon as I do that, what should be going off in your head?
The angles.
Yep, we're going to get that, right? By Isosceles Triangle Theorem. Now, I'm not going to write it yet, because remember when I add stuff that isn't here, right? I need to write stuff down here. And a classic mistake is to go, oh, look! And then forget to write it, right? So, I'm not going to write it yet. Then DE and EF are the same. Okay, cool. No alarm bells there necessarily, right? AEF, DED the same.
Have you seen Bartles?
I have not. So those two angles are going to be the same. You dig? Okay, cool. So we're going to prove AE and DE the same. So same thing as before, right? So we'll end with these two being congruent. We got to prove these triangles congruent, right? That's going to be the key. So you said alarm bells first off, right? These angles are the same. By Isosceles Triangle theorem, because we started with the sides and got
I
the
just saw
angles.
Bartos.
Oh, you did?
He just walked.
That's funny.
Amusing.
All right, cool. So we've got an angle and a side. This does not apply to this triangle, right? Because it's talking about this big angle. Now we can use that to maybe get this guy, right? So check it out. Here's the logic. We have overlapping congruent angles. These angles are both the same and they overlap. So we can use angle addition postulate. Here's the logic, okay? Green minus DEF, this angle, right? Gets us that. Does that make sense? Green minus this angle gets us that angle. You with me?
No.
Okay. So we've got green angle like this. And if I subtract this from the green, what's left over is that. Does that make sense? So this angle equals whatever the green angle is minus the black angle. So up here, green angle, this one, right? Minus the black gets us this. You with me? This is also green angle minus black gets us this. So this angle is equal to green minus black, right? And this angle is equal to green minus black. Well, if they equal green minus black, then they equal each other, right? They both equal the same thing, right? They both equal 5, then they equal each other, right? Well, I'm saying they both equal green minus black, right? You see that? So that means these must be the same. Again, I didn't say black was congruent to anything. I was just taking out that angle, right? It's the same angle for both. They share that middle, right? So green minus black gets me this. Green minus black gets me that. So they're going to be the same angles. Guitar, how do you feel about that?
Good.
We say by angle addition postulate, and you're being like, wait, we just did subtraction, right? That's true. Well, we're using it in reverse. So normally you'd say like orange plus black gets green, right? Orange plus black gets green. So the greens must be the same, right? We're using it in reverse by doing algebra to subtract instead of add, right? So it's the same thing, but we're using subtraction. So green angle, I can't call it E, I gotta call it something else. So AED, I'm gonna use the 3-letter name. Congruent to BEF, def. All right, so now we got those. Angle, angle, side. Triangles are congruent, right? So this and this are the same. A and D go together, D and F go together, E and E go together. With me on that? Okay. Now if the triangles are the same, their parts are the same, right? Question is which ones? The corresponding ones, right? I want AE and BE, first and third. Yep, I can do it. Segment. And I win. Because that's what they wanted. If they said prove that E is the midpoint, then I say by definition, E is now a midpoint, right? What do you think? Gucci? Want me to back up and go over it again?
What?
Want me to back up and go over it again?
No.
You sure? Feeling good about those overlapping congruent angles? Okay, angle addition postulate. 4. ADEB is a line segment. That's all it's saying. So that's a line segment. There's no bends or anything in here. It's not like a slight bend somewhere. It's all one line, okay? Then it says AE and BD are the same segment. So AE and BD. Ooh. Again, I didn't put a tick mark because then it looked like 80, right? If I put a tick mark there, then it looked like D. I'm talking about the whole thing. So I had to do this fancy bracket, the squillium eyebrow. So overlapping congruent segments. Similar to overlapping congruent angles, right? Red minus DE gets this, right? Red minus DE gets that. So these are the same. They're both equal to red minus DE, right? Won't write it yet, but we will. That's segment addition postulate because we're working with segments now instead of angles. All right, CD and CE. These are congruent segments. So CD and CE are congruent. As soon as I do that, you should have alarm bells. Isosceles, right? Right? Okay. Then ACE and BCD are the same. So ACE is this angle here. Ooh, this angle here goes all the way to ACE, right? And then BCD is this. So we have overlapping congruent angles as well. That's angle addition postulate, right? Blue minus this gets that. Blue minus that gets this, right? We're subtracting the same thing for both, right? So already lots of things we could write down. Let's get the easy thing first, this guy, right? That's the theorem because we have the sides, right? So now we get the angles. Angle, can't call it D. I got two angle D's. So I'm going to say CDD. Congruent. Angle CED. Remember the middle letter always has to be the vertex, right? Okay. So that means this. Don't forget to mark your diagram after you write it. Okay. Oh yeah, it doesn't say what we need to prove. This is an old copy. What do we have to prove for this one?
AC and BC.
Okay. Thank you. So our goal is to prove that this side is the same as that side. So again, these two triangles congruent, then we get that by CCP, right? Or if we were able to get that angle and that angle, then we could use the converse, right? To get the sides. But we're going to get the triangles. So we've got that. That gets us one of the sides for our triangles, right? We also know by angle addition postulate that blue minus this angle is going to get us this angle, right? And the same thing over here. Blue minus that angle gets us this. So these must be the same, right? Both of those angles are equal to blue minus this angle. Cool. So by, that's angle addition postulate because we used angles, right? We know angle ACD. Again, can't call it C. Gotta use the full letters. BC. So now we've got a side and an angle. That's good. Down here, overlapping segments that are congruent. Red minus DE equals this, right? Well, this guy also equals red minus DE. So they're both the same. So I'll mark that with purple. So by segment addition postulate, I know that AD is congruent to BE. These two segments. So now I've got side, angle. That's ass backwards. So unfortunately, this isn't a right triangle, so we can't do it, right? So we need more information. This is the part almost everybody misses. So far, you feel good about this stuff? Okay. We used everything they gave us pretty much, right? The one thing people miss on this one is
Other than that, it's being taxed.
these two angles add up to 180, right? Because they're on a straight line. So that's linear pair theorem. So 180 minus the green should get us this, right? Does that make sense? 180 minus green? Well, this angle is also equal to 180 minus green. Does that make sense? So these two angles must be the same. By linear pair theorem. Linear pair says two angles on a line add up to 180, right? So if that's whatever it is, this is going to be the same on both. Cool. And now look what we have. Side, angle, side. We also have angle, side, angle, and angle, angle, side, right? Got lots of options. Sometimes that happens when you get that last piece in and unlocks lots of ways to do it. I'm just going to do side, angle, side. Okay. I'll say that these two are congruent. All right, A goes with B because purple and unknown, right? Purple and unknown. And then I've got C. So C is this angle on this triangle. That's the green and unknown. So I've got green and unknown over here. It's going to go with itself. D is purple and green. Purple and green over here is D. We cool with that? I'm going to prove AC and BC the same, these two segments, right? So what we're going to do is CCB. AC, BC. Right? How you feel? These? Again, the key was to see that linear pair. So now, again, the way I organize these things is very smart. We know about segment addition postulate, same thing as an angle, right? Two congruent segments overlapping. Take out the overlap, what's left over is the same, right? Now we know about linear pair. If we have two angles adding up to 180, we already know those two match. Then the other two must match, right? How you feel? Good? No. All right. Guitar.
I'm confused about the side angle side. Why you wrote ACD?
I wrote ACD for this triangle. You could have wrote ADC.
Okay.
It's okay. It's okay. It doesn't matter. If you wrote ADC, then you would write over here, A goes with B, right? D goes with E, and then C goes with D. You would have written that. And then when you did AC and BC, you would have done this. Oops. Did I miss a thing? Oh yeah, it's not D, it's C. Right? And see how they're still corresponding, right? It doesn't matter what you write the first one as long as you follow the second one, make sure it lines up right. Okay. Feeling okay? That was an easy problem to have. Good. Let's look at 5. Yeah, if you're gonna be confused about something, that's a good thing to be confused about. Easy to fix, right? All right. 2 parallel segments. FCG is parallel to ABE. If you remember from last semester, if we have 2 parallel lines and they're cut by another line, that line is a transversal. And corresponding angles will be congruent, meaning that if it's the top, see how we have an intersection here? Top left corner of the intersection is this. If I go down here to this intersection, top left corner is this. If they're parallel, those corresponding angles will be congruent. Corresponding means same relative spot, right? Top left, top left. Same thing here with top right and top right. And you know by vertical, these are the same, right? Top or bottom left should be the same as well, right? And then same thing here with vertical, right? So when we have parallels, we should be looking for corresponding angles, right? So that's something to think about. AC bisects BCG. Okay, so here's BCG, BCG, right? This angle right here. It's a big one. And it's being bisected by AC. Bisect means to cut into equal pieces. So it's cut into this piece and that piece, and they're the same. Doesn't look like they are, but they is. Because I said so. Okay? Then we've got D is the midpoint of AC. So here's AC. And D is the middle. Which means this and this is the same, right? Feeling good about that one? Cool. So here's what we want to prove. We want to prove that BD, this segment right here, bisects, cuts in half, angle ABC. Here's ABC, it's this big angle here, okay, the bottom of that triangle. So we want to prove it cuts it in half. It obviously cuts it, right? Question is, does it cut it into 2 equal pieces? So if we can prove this and this are the same, then we win. Now those 2 angles belong to these 2 triangles. So if I prove the triangles are the same, then I get their angles are the same, right? So I need to prove these triangles are the same. Right now all I have is 1 pair of matching sides. I don't even have a pair of matching angles, I just have the 1 angle, right? So I need a lot more information. So here's what we're going to do. Always, always, always extend your parallels, okay? So I'm going to extend that into X for Xavier, okay? And the way we do that is we say let XABE exist, right? Let there be, if you want, you can put there be, right? Let there be a line such as XABE. Okay, cool. Sorry. Then I'm going to extend one of these lines here that can cut it so I can get something like this. Does that make sense? I'm going to choose this one. You could choose the other one. It would work the same way, okay? I'm going to extend this one out. And when I extend it, I need to extend it into something. So let's use, we already used G, so we can't use G for guitar. Let's use L and M. So I'm going to say let there also be L, A, D, C, M. Okay? Cool.
I needed to write Miss Palmer.
That's fine.
I just ran into Miss Palmer for like an hour.
And I needed a break.
That's fine.
Like my brain is hurting.
All right, so and Anna, I'll be with you in a second. Are you good?
No, I have to leave, but I have like very little problem.
Ask me a question. How do you feel? Can I help at all or no?
From the last page, I worked with
Don't do that. That's self-development.
Okay.
That's
Big
not-
cups.
I tried, but those.
These ones. The setup looks good. You know B1 plus 2 should equal B3, right?
Yeah.
So now you can take that and you can plug that in here.
Okay. Do you have any
works for me.
That's okay.
And can you, I'm gonna staple this, and then you're gonna put it in the bin back there, and you're gonna remember it's in there. So when you come in, I'll say, go get it. Okay?
Doctor, need the water.
Rad. All right. So, check it out. Now that we've done this, we don't care about any of this crap. Okay? We have two parallel lines being cut by a transversal. That's this. Do you see how this is the bottom left corner? This is also the bottom left corner. We have two intersections, right? Intersection here, intersection there. Bye. Bottom left add up, right? Or they're the same. So we say by corresponding angles postulate. Corresponding angles, right? Same relative location. Postulate because it has to be true. There's no way to prove it, but we just know it has to be, right? So corresponding angles postulate, these two, right? We know that angle DCG is congruent to angle LAX.
See ya.
Now, that's why it was important for us to put these points here, so we had a way to call it something, right? Because there's lots of angle A's, right? So now we're good. You see why those are congruent? Okay. So now, that didn't help us a lot out of time because we want to know about these triangles, right? That's not an angle in our triangle. But we have an x, so vertical angles, right? Remember that from earlier? So by vertical angles, these are the same. All right. I know that angle LAX from before, right? Is congruent to angle DAB. Don't you dare. Don't do it. Don't do it.
Your L looks like the angle
I
sign.
know, I'm sorry. I know. That's why when I do my angle signs, I make sure to sit them on the ground, right? Because there's also less than signs in the notes, right? I gotta be very particular about how you write stuff. All right, so we good with this? So now we've got matching angles and sides. That's good. What else do you see? These two triangles. Yeah,
You share a side.
they share a side. Yep. Ha. Don't miss that, right? So if I shared side, DB is congruent to DB. Now, we got a lot of information now, but we have a problem. We've got to ask, right? No right angle, so we can't use HL, right? We can't call that the hypotenuse in that way. So, we need more information. Don't forget to look at the big picture.
So Isosceles. It's an oyster.
You see them? Isosceles, right? The big triangle, two matching angles. So two matching sides. You see it now, right? That's the converse where we have the angles and it gets us the sides, right? So by isosceles triangle theorem, converse, and we said sides. Sides AB and BC are congruent. And now we've got enough information, right? We can even do side if we want. So we got side angle side. I'm gonna do side. I didn't say that these two are congruent. Side. Okay, I'm gonna zoom out so you can see the diagram still. So by side, I know this triangle, ABD, is congruent to triangle. Okay, now we gotta match them up. A is red and green. Red and green is C. B is green and blue. Green and blue is also B. And then, ooh, we did it again, boys. Red and blue is D. Red and blue is D. We did it. It's letters.
Why is it side?
We could also do side and angle side.
I thought you can only skip one.
Side, skip, side, skip, side.
I thought you said we can only do one time.
One at a time. Does that make sense?
Oh,
Does that make sense, right? Side, skip, side. That's okay, right? You just can't do like side, skip, side, right? That's not okay. Does that make sense? Okay. Also, side angle side works. Okay. Either way. So these two triangles are congruent, which means their parts are. So remember, I want to prove that this guy bisects this angle. So I want to prove that this angle and this angle are the same. And I can because CCP, right? That's angle ABD D, right? So first, second, third, perfect order, right? Should be congruent to C, B, D. And that is this angle, right? So that means that by definition, does DV bisect that angle? Yeah, because it's in two equal halves, right? So by definition, BD bisects angle ABC. Be sure to write it just like they did at the top. Done. Extend, extend, cap, right? Corresponding angles, vertical angles. Isosceles, triangle theorem converse, side, 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 CCP, by definition. When you're good at this and you feel like you're getting it and you nail the stuff, you feel like a fucking badass, right? You want to be that. You're not going to get there today, but you're going to be a lot better than you were, right?
I'm always there, man.
Ladies, can I help?
I don't know. We're still talking about our life problems.
All right, well then do that.
Get over it.
I have some
Make sure you put those in water so they don't die. 6.
I used to play catch with my goldfish.
Great.
Only
See
thing
ya.
is, the goldfish was the ball.
As soon as I do this, alarm bells should be going off.
Square.
I swear to God. Okay. Yep, that's a square. All right, and then FAB, FBA the same, right? So we get those two little angles. The red's going to get us the whole thing, right? Okay. ADF and BEF we want to prove congruent. So I'm going to mark that so you can see what we're trying to, what our goal is. Just letters are hard, but like pictures are good. So these are the two pink triangles I want to prove congruent. Okay. Right now I have absolutely no information about them. So that's a good start. How do you solve a problem like this?
You've got the isosceles.
Yep. So
Oysters.
is that the theorem or the converse?
Converse.
Why?
Because it's angles.
We're getting the angles, or we start with
We
the angles?
have the angles.
We have the angles. Ooh, so you're saying, okay, so this and this, converse, right? Okay. We know AF and BF congruent. BFAF.
Annoying fucking best friend.
Or best friend as fuck, right?
No, that'd be the other way around. It stands for annoying fucking best friend.
Is that what the kids say? Gotcha. All right, so here we go. What else do we have? Now we have at least one
We
side.
got a bunch of vertical angles.
Ooh, vertical angles. I'm just gonna put the ones down that actually are part of our triangles. Okay.
They're all part of the triangle.
Part of our triangles. Actually, this one is not. It's part of a kite, which we'll learn about later. They have properties too. So this angle and this angle are the same by vertical, right? By vertical angles here. Angle DFA is congruent to angle TFE. Okay, so now we have two angles and two sides. We get a pair of angles, pair of sides. We're on our way. If we can get another side, then we get side, angle, side. If we get another angle, we get angle, angle, side, right? Or this angle, angle, side, angle.
Can we do an isosceles by this side?
So whole thing's an isosceles triangle. So by the theorem, we get the angles, right?
Gotta subtract the green from the red.
Yeah.
Hate Christmas colors.
So by isosceles triangle theorem, we know angle DAB, don't you dare, is congruent to angle EBA. So here's the logic. Red minus green gets this angle. Red minus green gets this angle. So both angles are equal to red minus green. Then they're equal to themselves, to each other, right? So purple.
We're finished.
By angle addition postulate, we know that angle DAF is congruent to angle EBF. Cool. And so now are the triangles congruent? Angle, side, angle, right? So by angle, side, angle, triangle, write it the way they want it, ADF, congruent to BEF. Beth, as in your Beth friend, AFBF. That's 6. How do you feel? Guitar? Red. 7. All right. EGBG. That's these guys.
Oh, wow.
Right away, isosceles triangle theorem, right?
It's a baby triangle.
It is. They gotta start somewhere. AB and DE are the same thing. Ooh. Segment addition postulate. CG and FG. I'll be there in just 1 second because they're gonna try this on their own. CG and FG are the same. Now notice those tick marks only apply between C and G and F and G, right? We're gonna prove angle A and angle B the same. So angle A and angle D are part of one triangle each, just these guys, right? So you need to prove those two big guys the same. Right now you have a side, right? So that's good, right? You have one side of the triangle. I bet you can figure out the other side using segment addition, right? And if only you had an angle between those, you could do side and side. Try it on your own.
Talking about
Fine. It's okay. So you know what V3 is. What is V3? Yeah, it's 10, isn't it? So it's really V3. It's right 10. Cool. So you need to get rid of one of those. So if only you had a way to say like V1 equals a bunch of crap or V2 equals a bunch of crap, right? And then you can switch it out. Do something with it. Can't you rearrange that to get V1 or V2 on its own? And then you can substitute, and now you're only dealing with one variable. Yep. So you know V1 equals all that crap, right? So instead of writing V1, can't you just write all that crap? And the advantage of that is now you're talking V2 and V2, right? Don't forget to distribute.
What did you just do? Did you like slap his ass or something?
No, I did not do that.
Did you?
No, I did not.
That would have been hella funny if you did.
I did not. I try to refrain from doing that as much as possible. As a general rule of life. All right.
That's fine. You just locked something out of the house.
Go get it.
Sorry.
What are these? Reese's? Like super tiny.
Those are my favorite. They're my favorite. And John just ate all the rest of mine. Gave me that.
With permission.
I saw my sister
Yes.
for the
Fuck it.
basketball game, and it didn't start until 4, so I guess it's a long
Encourage.
Shit.
What was your?
Bullshit things. Alright, Mac, which one says that, like, you know, you gotta add these two together? Fucking is that-
Segment addition postulate, the two little pieces, yep.
Okay.
That's like the straight up segment addition, right? Add these two together, you get a big one, right?
Is that the one I used for subtracting two?
Yo, what?
Yeah, subtract.
The same thing for segment addition. It's really kind of like a converse, but we don't worry about that.
Wait.
Are we doing side, side,
Oh.
side? Do we have it?
Can't do side, side, side.
Oh,
Wait, I have a question.
I don't know what to do.
I have a question.
I'll show you. Yeah.
I had to like multiply by this. And
Yeah.
multiply by the top, right?
Multiply by the top and divide by the bottom, right? It would help. You could simplify 5/10, right? Or don't, and divide by 10 and then times by 5.
Alright.
All right, so here's what I would do.
Don't interrupt me, Mac.
I
I'm
won't.
working.
So I would say, first and foremost, do what you want. Pretend it's class.
Are you telling me to
Yep.
ignore you?
Yep, that's what you want to do.
Uh,
So these two are the same, right? Y by segment addition postulate. So by segment addition postulate, I know that CB congruent to FE. So now I've got two sides, right?
Mm-hmm.
Then look at the little triangle.
I
Oh.
wrote for segment addition possible. I wrote CDB equal FGE.
CGB, FGE. That's fine. That's fine. That's fine.
Okay.
Mhm. So look at this little triangle.
Mm-hmm.
It's isosceles.
I did that.
So these two angles are the same, right?
Mm-hmm.
So by isosceles triangle theorem, right? No converse, just the theorem.
Mm-hmm.
Angle GEB is congruent to angle GB.
Oh, I wrote
And then we win. GE.
equal GB, but not the angle.
Gotta have. Oh, the line segments? Yeah, that was given, right? That's given. Hey,
Oh, okay.
the angles, right? So the theorem, right? And now we win. Side, angle, side. Do you see it? Side, angle, side. Big triangle, right? Yeah, uh-huh. Overlaps are hard.
I wrote the AAP before.
Angle addition?
Yeah, I wrote AE equal BD.
Ooh, these two? You could do that. Yep, that's fine. But it doesn't help because this isn't part of the triangle, right? It's not the whole thing, right? So we don't need it. It's true that red minus EB equals this. Red minus EB equals that. That's true. But it doesn't help, right?
I don't know where is CBA, like how can we see? I don't see the SAS.
Ooh, okay. S, right? A, S, red.
Oh,
Yeah, so you don't need that. You just need this whole thing. Could you get it? Sure, right? But like it's not helpful.
okay.
Better? Good question. All right, and then if those triangles are congruent, their parts are congruent, right? So I can say by CCP, A is the same as D because look, A and D, right? Both in the third position. The way I wrote it, right? You might have written ABC or something, right? And we win.
I feel like I'm doing this wrong.
Okay. Let's look at, how do you feel about 7?
Good.
Good. Did you nail it?
I don't know.
Well, I mean, did you or did you not?
I mean, I did it.
Okay, then that's great.
If it's right or not.
Well, is it like mine? How's it different?
Well, it's not in color.
What else?
I don't know.
Okay, so you are saying by this, these two angles are congruent. Solid?
Yeah.
Yep. And then you said by segment addition postulate, I know that this and this is the same. That's true. It's not going to be very helpful though because that bit is just part of like this like quad, right? So it's not super useful, but it's true. Oh, you're talking about something else. CBFE. Yep, that's good.
Oh, yeah.
So these whole things are equal. Yep. That's good. I would then like do something like that. So you know that's good. I don't know. Maybe that makes it look worse. I don't know. But yeah, that's true. So we have side, we've got angle, and then we're already given the side. So by side, angle, side, we can jump down here and get it right. You said SAP, which is true. Segment addition postulate, these two are the same, right?
Oh,
But it doesn't, we don't need it, right? Because that only applies to this quadrilateral, right? It's true, but you didn't need it. You already had side angle side.
We have to find the perimeter.
Yeah, every individual piece, right? And then by CCP, these are the same, and this angle is the same, and those angles are the same, and this angle is the same as that.
No, it's not.
It will be because by linear pair theorem, these are 180. So 180 minus this angle gets you this.
But it's not.
And then 180 minus this
so
angle gets
it's
you
not
this.
true yet.
Right. Ocho. Try 8 on your own. It's not easy, but it also is once you see it. Okay, stop. Don't mix fractions and decimals. That is not 0.5. It is 5 over 10, which is half. Wait. Oh, you're doing, okay, so you're doing 0.5 over 10? Girl, that's not any easier. Yeah, did that, why change it if it makes it harder, right? So let's keep it 5 over 100. And let's keep this 5 over 100. You're right, 0.5 over 10 does work, but it, yeah, it's not a half, right? So 5 over 100 times 10 is going to change here, okay? So we're timing by 5 divided by 100. So let's divide by 100 first. What's 10 divided by 100? 10 divided by 100. 1 over 10. Remember, times it by 5 and get 5 tenths, which is half. So that's going to be good. And then we do this, right? Minus 5 over 100. Okay, so that over 10. So we just do all kinds of different notation, right? We use mixed numbers, we use proper fractions, and we use decimals, all in the same problem. And that's 5 over 100 is, and that one. So now we're combining things. That's 30 over 100, right? You can put those together. That might help. So try that. And then, I like how you switch back to improper. Good job. Improper is so much easier to work with. Like 9 times out of 10. 10 times out of 10. You can or can't?
I can do it.
Good. Alright, so these two are parallel. Let's see if they're the same. D is the midpoint.
But what you can see.
Alright, you ready to see it? Once you see it, you're gonna be like,
What?
So,
Very like get some stuff.
always extend your parallels into X for Xavier and G for guitar. Alright, so we're gonna say let
Do we have to write that every time?
CDX and UG. Let them exist.
How can I know that which line I'm
Always extend your parallels.
like which line I'm gonna cut?
Ooh, good question, right? Because we have this one, right? And we've got that one. You can do all of them, okay? I'm going to do this one because that's going to get me angles inside, right? If I do this, I already know about that angle, right? Not very interesting. But if I do this, that's going to help me see these guys. So, something like that. Now check it out. This is amazing. You ready to watch? You see it?
Why is there a symbol on the wall?
Right?
Are we doing corresponding?
Yep. Whenever you have parallels, look for corresponding. See how this angle here, right? So it's going to be here and here. Do you see it? They're corresponding, right? If I turn it back, still see it, right? So by CAP,
I already have that.
angle, nice, CBA, congruent to EDB.
You're buying the times back.
Well, I did do this already in class with you, so, you know,
I was paying
It's
attention
420.
like usual.
that's true.
I-
What?
420.
right now?
Yeah.
Oh man. There's a joke right there. All right. These two angles. Now check it out. Angle, angle, side. Right? So you win. Yay! Always extend your parallels, right? And even extend them further out if you want, right? On both ends. And
Do we have to extend them?
you don't have to, because if you just see that, that
That could
works.
save me a lot of writing.
Yeah, that's fine. That's fine. I don't care. As long as it's true. You gotta be careful though, because sometimes it'll look like they're the same, but they aren't.
Can I just like draw the lines, but like not write it?
If you don't end up not using those letters, then yeah. Like before we had ended up using those angles, right? This one we didn't really have to. 9. 3 more and then we're done. CD and CF are the same thing. So as soon as I mark this, alarm bells, right? D is the midpoint of AC. So, oh, look. If D is the midpoint, then all of these are congruent. Same thing with F being the midpoint. Yay! And then angle bay is angle AB.
Wait,
these-
so AD is the same as DC?
Yeah, right? It's gotta be.
Shit.
So bay, BAE, is the same as AB, ABE. Again, lots of alarm bells going off here, right? Prove ADE is congruent to BFE. Lots of triangles. Let's mark which ones we want. We want these two pink triangles. Back, it's only 2 that are in the diagram that are provably false. These big guys can be pretty congruent. No, everything's about those. Oh, and these big guys. Can be pretty congruent. Lots of triangles in this diagram. All right, that's the ones we want.
She couldn't draw that view.
What kind of number you're on now? Yellow. Okay, so you got lots of stuff. Yeah. Okay, so you decided to start here, which has neither of those you want. Why not put pints on the bottom so you can start with pints on the bottom? Okay, try that and then make things go away.
Do I have to put all of them or just one?
I don't you dare look at all these things, okay? You're gonna screw yourself up. Start over, start down here with this one flipped, okay? You'll spend way too much time trying to figure out what to do instead of just doing it. I will help you as soon as I'm done with these two next to promise. And then I'll make all the quizzes for tomorrow, which won't include algebra.
You don't have any tests on? How does it work?
No. But you would know that if you were here for at least half the class and were paying attention when you were here.
I have class today, okay?
I know, but like, we need, like, life's gonna suck and things are gonna be bad, that's gonna happen. So what you need to do is when it's not that bad, today's not included, right? Today's not included, today sucks, right? But when it's not that bad, you really need to make sure you get everything you can during that day. That way when bad days happen, you can take it, you know what I mean? So when we have our good days, we need to max those out. And then hopefully we can start working on having more good days than bad days, because right now we're on a bit of a rough patch. Yeah, let me know how I can help so I can help you with math, right? Like I'm not just helping you with your life to help you with your life. I'm doing it because if I don't help you with your life, you're going to suck at math.
And then
My
he
job is
gets
to
a
make you
pay
good at
cut.
math, right? No.
Or fired. He gets the axe.
All right, so
Alright, yeah, so
you want me to start messing with it or give you more time?
I'm trying to focus here, man.
Oh,
You
sorry.
can't keep interrupting me. People these days. See them working for once.
All right, so gallons are going away. Now we got quarts, quarts are going away. We got cups, cups are going away. Now we got tablespoons over quarts. Yeah. To what? Hold on. Right? Wait, 3 gallons. All right, where'd you Yeah, that's one way to do it. And you know you're right because things go away and it shows you that it has to be, right? That's the beauty of doing it that way. And then when you're done, Jordan, you can teach Olivia.
Okay. Shoot.
I'll print off some more reviews, that way you guys can work together.
I don't know how to like.
Yeah.
I just did 12 times 4 in my head super fast.
40 plus 8. Or 24 times 2. Okay. Have a good time.
I'm pretty sure I may have finished.
That's rad. All right. Guitar, how you feeling? Okay?
I think I got it. Maybe I have to go.
Ooh, okay, I'll check. Okay, segment addition postulate says A, C, and B, C are the same thing. Yeah. Angular addition postulate says D, A, E, F, C is the same thing. Yes. All right, B, yeah. Vertical angles. Good. This guy. Yep. Then we've got angle, side angle. Ooh, close. That angle is not part of this triangle. So by angle addition postulate, this angle, and this angle. Did you write that down? Oh, you did. You just didn't mark it. That's okay. That's okay. So angle, side angle, and then the triangle's congruent. Nice job. Yeah. Don't you feel amazing when you get it done?
Yeah.
You're like, when I used to teach this class, right? I'd be teaching up here. My old schools, I didn't have this, so I teach up here. I get done with the big proof, and I just go.
Oh my gosh, your cap came off and it broke.
Yeah, I know. I threw it lightly. Normally, you can make it explode when I've seen it before. It's amazing.
The janitors must have hated you.
No, they love me. I love them. Oh well.
You exploded markers all over the floor, Mac. Are you sure they just weren't being courteous?
It's pink, so no, pink's really good.
Yellow.
I don't have any red ones. I think red's a good marker. Can I get rid of all my red?
Just put tape around it.
Grant like made my day. I was like in the hallway and I like waved and he was like, "Hello, Olivia." And I was like, "Who?" Grant.
Oh.
Dad, can
Grant is
you get
wonderful.
this approval? Am I get approval?
Yes, as soon as I find a pen cap, I don't mind tech, but pen. There's a crappy green around here somewhere. There's got it. Oh man, that's a really good green. Okay, so I
Can I
guess.
draw something on your board?
Can you write what?
Oh, can I draw something on your
You
board?
can, but like be careful to use all the markers I have in here and those eraser.
What are mine?
Not necessary.
These like don't work.
Always appreciated.
I'm
Yeah, they're
gonna
not.
do this for
I used to use them when I would do Windows, right?
Whoa, this is cool.
Like at my house, I don't have a whiteboard, but I had like a
I'm mad
window.
because I wrote
Give all
on
those
the table
appointments.
All right, so I'm gonna go for it. Oh, you're going to the next one?
Live?
Yeah, I'm live.
Really?
Yep, right now. I'm doing it that way people at home can watch.
Why
Cause
you're lying?
This is what I got for that
Special.
one
For
thing.
sure.
let me see. What do we got?
Sure.
Segment addition says these are the same. If these are the same, then by
Should I say follow me
theorem,
on TikTok?
C, D, F, and C, F, D are congruent. Yeah, that works. Those two angles. Don't really need it, but yeah, that works. Isosceles triangle theorem. Yep, we get those two. Angle addition. Yep, that is orange minus green. And then we can say for the converse, we get these sides. And now we've got side angle side, so we win. Yeah, well done.
Professional.
Yeah, doesn't it feel amazing?
No.
Let's do 10.
I'm working on it.
You wanna try it on your own? Red, you do it, I'll do it. That way the folks at home can watch. I won't say it out loud, I'll just.
They're all disappointments.
That's my favorite.
That's good. I knew it. Yeah, because he said it's the purple one. Yeah. What happened to this?
It was on his Instagram too.
Right.
What happened to the pen?
Yeah. Did you like print?
Fuck, what?
No, that was from the past teacher. I don't know what happened. Ask one of the older kids, they'll tell you.
What?
This pen right here.
No fucking idea.
It's
I
not
was here
black,
for
so
years.
sorry, man. I found another one.
Have a bathroom break.
Is this the one we use?
Are you working or, like, do you want me to, like, not do this so you don't see it?
What?
Or
No,
are you good? You're good?
I'm attempting it.
You got like 5 million black ones.
Yeah, I know, I just bought
You're like
it.
obsessed with black. or
Because they're
something?
cheaper and I bought them in a large box. I don't use that enough to really need color up there.
Can I like buy you these ones back?
I prefer if you did.
But like, I don't
It's
know.
always appreciated, but not
What if I
necessary.
want to?
I cannot stop you, but again, appreciated, but definitely not necessary at all.
This is extortion.
Okay, can I write like Jordan's the best?
Yeah, go for it.
This one's the same.
Live your best life.
I can't write big.
Yeah, it would be fine. It's so quiet in here while I'm just writing. Frick! This is my D, okay?
What the heck? Sorry for being not
You're fine.
on the ground for this.
You could be teaching Lydia stuff.
Yeah.
I will print a review guides are in the copy right now.
Oh, so you're Are we allowed to go in there?
No, because I have used my key to get it out of there. Like it hasn't started printing yet. It's just being sent there, and for some reason there's like a 10-minute delay this semester between when I send it and when it actually arrives.
It's not a straight line. I can always draw straight lines. My apologies.
For real? Like diagnosed?
Oh, probably.
Okay. Well, if you're not diagnosed, also what people colloquially think bipolar is way different than what it actually is. A lot of people think it's like I have mood swings, and that's not what bipolar is.
Wait, do you have dynamic or something?
Yes, but why are we talking about that?
She sees us on the board tomorrow.
So,
Jason.
not in first hour, in fourth hour. But yeah, I do have it in class.
Who's like, who do you have in my grade?
Jared Foreman, Taylor Swanstrom, Shelby Belcher.
Shelby.
I don't know.
I don't like how this is big. This is just
Oh.
Hi, Mr. Mack.
Hi, Dana.
It's Mac's favorite.
Hi.
I don't have shoes on. We
I'm live streaming this right now.
Hi, Mr. Mack.
Hi. Hi, I'm live streaming this right now, so you can go and watch. I'm doing all the problems we didn't get to do today.
Oh,
Hey,
I'm
I'm
gonna
gonna
get
do
the
the
quiz.
Me too.
Bye to my future self.
Okay, bye.
Okay, bye.
Bye.
Have a nice day.
Hey, you too.
Love you, Diana.
She doesn't love you.
I know.
Hey, I know, especially this part. I'm gonna
I don't really like that.
okay, is it weird that I can write my first name poorly and my last name good? Like, good handwriting?
I don't know if that's weird or not.
It's weird.
It's a thing.
So that means by what the fuck's it called when they're the same triangle, so parts of them are the same?
CCD.
What is it?
See, look.
CCD.
It's sloppy right here and perfect right here. I don't get it.
I'm sorry.
It's not really
So now,
It's sloppy and crooked, but
not that easy to be able to like, hey, I'm gonna online school my kid. Everyone wants to do it, but it's really not that easy. Also, you shouldn't do it because it's an inferior education, like 99 out of 100 times.
Oh, like, okay. If it was easy.
It could be. I mean, I'm not saying it would be easy. It wouldn't be easy. It might be, but you're gonna get a really crappy education. Like, no one's like, hey man,
What if I like?
I went to online college and it was the best thing ever. They're like, I went to online college and it mostly worked, right? So imagine what online high school will be like. Even worse.
What if I like just came to your class?
Fuck it.
I guess I'll take it. You get it?
Oh,
Oh,
yeah.
I see what your proof is. I almost did too much, actually.
I just
Alright.
started doing some
So
shit.
we know these two, mean these two angles are the same, so EB, wait, hold on. Those two angles were given to you, right? This angle and this angle, right?
DAE.
Yeah, DA. Okay, so by isosceles triangle theorem converse, because we have the angles and we get
Why are people calling
the
this?
sides. It's okay. So those two are correct. And by shared side, ED is the same. Yeah, that's right. And by shared side, CE is the same for those two triangles. Yep. Supplementary CD by SAP. CD. Where's CD? Oh, SAP. Got it. Okay. So segment addition postulates. It's congruent to itself. Yeah, you could also use shared side there. That it's a shared side for both the big triangles that we're trying to prove. SSS. SSS here, because these are the same, and then by CCP those angles are the same, and then by SAS,
I want to be a teacher.
Yep, nice.
I want to teach.
Not efficient, but still really good. 11.
Need to press it.
Teach Olivia something, because I'm almost done with Xavier, and I'm going to teach her after this. You need to review guys? I need you guys right now.
So I have to leave right now. No backpacks in class. You don't like backpacks in class. Math. Okay, go ahead. Okay, just hold on, okay?
What the fuck?
Casey's group up. Nice. Alright. You try 11.
No. I was gave a drink.
Okay. Alright. 11. Oh, we gotta change something on this too. I think DAE is right angle. No, that's not true. So we need DEF. My bad. You do DEF right angle. DBE should be ABC. My bad. I think I changed the letters after I was doing it. Those should be the right angles. My bad, YouTube. Alright. We know BC and EF are parallel, so that's these guys. You get two parallel lines here. Here, arrowhead should go in the same direction. Show they're parallel, and then AF and CD are congruent. So AF and CD. Now we're going to prove that ABC and DEF are congruent, meaning these two right triangles, that they are congruent. So these are our goals, these two guys, right? So right now we've got an angle. So you want to work on it on your own, or you want me to walk you through it?
I don't know.
Okay. So AC is the bottom of, or is the top of this right triangle.
It's HL.
So this bit and this bit add up to the whole thing, right?
Yes.
Cool. And this bit add up to the whole thing here. Now the problem is we only know one little piece. We don't have both, right? So what we're going to have to say is, so we're going to do shared side for this. So shared side by shared side. FC. Since AC and FD are both purple plus blue, right? Purple plus blue makes it up, so we know AC and FC are AC and FD are congruent. Let me restate that. AC and FD, yeah. Okay, so we know by state division possibility, AC, FC, or FD. Letters apart. So AC is congruent to FC, FD. So those bottoms are congruent. So we have matching bottoms now, and we've got matching angles. Notice that the bottoms are the hypotenuse, so if we can get one of the other legs, then we're golden. So how do you solve a problem like that here? We haven't used the parallels at all yet. So notice we have a line like this, right? And then we have two lines going like this. We already sent them out, right? So that means this angle and this angle will be the same. So if I were to extend this, right, and this, these angles would be the same. Yeah. And then by vertical, I can get this. So what I'm going to say is, if I extend this line out, let BCX exist, then I know that angle EFC is congruent to angle XC by cap. Right? So I know these two angles are the same by cap. Cool. And then by vertical, I can get this guy. And now I've got angle, angle, side for both of them. Again, angle, angle, and then sides. As long as sides, so that angle, angle, side. By angle, angle, side. I've got triangle ABC. Triangle D. So we proved their bottom's congruent because the bottom of the pink triangle is blue and purple put together, right? And the bottom of the black triangle is blue and purple put together. So they're congruent by SAT, right? Then I said these angles are the same here and here because of cap, right? And then by vertical I got this. Cool with that? So now I have angle, angle, side, angle, angle, side. Good. Color really helps with that one, I think. So you can see like what bottom we're looking at. Because the bottom of those right triangles, it's like trippy. Very trippy. Probably if I could have those segments there. I don't know what
Wow. Finish.
That's it.
I'm a genius.
How are you feeling? Right? Is that what you feel like? That's how I felt after I started getting proofs. Like, no one knows how to teach this stuff. Like, everyone's just like, well, know your definitions and your theorems. And best of luck. I've never met a geometry teacher that actually knows how to teach this stuff. But once I figured out how it works and the idea behind it, right? Get the triangles congruent, so you get the parts. How do you get the triangles? Well, you use SAS and all this other stuff, right? Don't forget to see the big picture, linear pair, isosceles triangle theorem, right? That's the key. And I think a lot of you guys are starting to get it, which is infinitely more kids that got it than when I took geometry. None of us got it. It was
I'm just gonna start stealing your pens.
And when I took geometry, here's what I did when I took geometry. They'd be like, reason and proof. And so what they would do is they'd give you the reason, and they'd be like, okay, these two segments are congruent, AC congruent to BC. How do we know that? And you'd be like, oh, I can fill in the blank over here, isosceles triangle theorem. And then down here they'd be like, vertical angles. Which angles are vertical? And you just fill it in. And it's basically just cheating, and everyone teaches it this way, not because it's good for the kids, but because they have no idea how to teach proofs. And this is fill in the blank, easy, know your definitions, and so they are teaching it. But you guys don't do that crap. No word banks, no, I give you half and you find the other. No way, Jose. Not once do we do that. You guys are all masters of it. Run circles on other kids. Xavier, the questions you asked today that really illuminated stuff for you were very simple questions that I could answer during class. You should ask them when you got them. And then I think the other key was that you pay attention, right? And we're really